what I want to do today is logistics. And for logistics, it's going to be the same diagram you're going to see every single week, which is basically this one that you saw last time. We're at week 2 today, which means that I want to spend the majority of the time today talking about Kotlin. In particular, I want to pick up where we left off from last week with the bigger number game, the Berkeley admissions test, finish that off. That'll give you a kind of a overview about some of the main features of Kotlin. And then I'll give you a more structured guide about what is so cool about Kotlin and what are the main features. In addition, I'm going to, depending on how much time we have, I think we'll be able to talk about Git a little bit and GitHub. And the reason I want to spend time talking about that is because I have a very particular way that I want you to submit your assignments. And so I want to talk about that today, because as we start doing the projects starting next week is project number 1, tip calculator. You're going to have basically a week and a half to do the project. I want you to follow the guidelines that I outlined today. And so for the rest of the class, we're going to start out with the bigger number app, Kotlin overview, and then finish up with Git and GitHub. Cool. What questions do you have before we get started? All right, bigger number game. So we had started talking about this last week. The idea of this game is that it's a very simple layout where you have 2 buttons on the screen, and the objective is pick the larger button. Depending on which number you pick, and if that choice is correct, we'll change the background color. So we haven't gotten a chance to talk too much about the Android mechanics underneath the app, but I want you to just know 2 things. First off is when you create a new project, then you're going to have, by default, a Kotlin file called main.activity.kotlin. And the 2 lines that I want you to pay attention to in this file are line number 6 and line number 10. Line number 6 is the declaration of this class. So it's main.activity.kotlin. Then activity, you can think of it like a screen on Android, right? And so line number 6 is basically saying, here is the main screen of our application. Line number 10 is saying, here is the content for main activity. So line number 10 is specifying that this resource, r.layout.activity_main, which is pointing to some XML file, that will define the UI or user interface for our application. That's thing number 1 that you should know, that association between main activity and the underlying layout file. Thing number 2 you should know is the communication between those 2 components. You have an activity, which is the brain of the application. That's like the Kotlin code, which will power your app, and a layout, which is the UI. And the way the communication works is in the layout file. Here on the right side, I have activity main.xml. Every component or every widget, you can give it an ID. So in this example, I have a text view, which is basically a label, and I can give it a ID, which is called TV Hello World. TV stands for text view Hello World. And so in the main.activity.kotlin file, I can reference that text view by saying TV Hello World, which is a pointer to that text view. And that text view will have different attributes on it, different methods on it. And so in this example, I'm calling the .text method, and I'm updating the text. So when I run the application, this method here on create will be automatically invoked by the Android system. This is called a life cycle event. Okay, so don't worry too much about that. We'll have a lecture talking about life cycle of Android components. But the main thing you should know is that onCreate is an event which will be triggered for you by the Android system. And so the code that you write here will automatically be run, which means that when you run the application, instead of the text showing hello world, because you wrote this line of code here, the text will now show updated text. Cool? Okay, so with that, I would like to come back to the code that we wrote for the bigger number game. All right, so I have the app running over here. So if you remember from last time, we just had enough time to write the logic for changing the background color when I tap on the left button. So 5 is bigger than 3. So if I tap on the left button, the background should turn green. So it turns green, and we also have this little pop-up, which is called a toast in Android terminology. And that shows up for the default time, which is, I think, 2 seconds, and it goes away. This game's not very interesting because right now we're not changing the numbers in the buttons. So the only really thing I can do is keep pressing 5, and I keep showing correct. And nothing actually happens when I tap on the right button. So the first thing I want to do with all of you is number 2, which is pick new random numbers. So as a brief reminder, what we wrote last time is button left refers to that button on the left side of the screen. I gave it an ID of btn left, and you can see that from the activity main.kotlin. Do you remember this? So here's the button. So if I select it or put my cursor here, that relevant component in the design tab will highlight. So it's this button over here. So I can say btn left. There's a method on the button called setOnClickListener. And what you're doing here is, in reality, what you're doing is you're passing in an anonymous Lambda function. And really what that means is you're writing some code which will automatically get invoked or run when this button is clicked. It's an event listener. There are 2 things we're doing when we click on the button. Number 1 is we compare the numbers in the boxes to determine if you want to turn the background green or red. And number 2, which is what I want to do with you right now, is after the button is clicked, I want to pick new random numbers. Cool? So I am going to actually delegate the work of picking new random numbers into a function. So this is the first time that we're going to write a function together in Kotlin, which is really exciting. So I'm going to call this assign numbers to buttons. And right now there is no function with that definition, right? And so one trick that I can share with you is when you have this red highlighting, that means that something has gone wrong in your project, right? So oftentimes Android Studio can help you fix that. So if I hit this red light bulb, there's a option here for create function, assign numbers to buttons. And so if I tap that, Android Studio will automatically create this function for me. So I'm going to get rid of the to do. And our job here now is to randomly pick new numbers and change the text on the button to be those new numbers. So the way you declare a function in Kotlin is fun. Functions are fun, right? So this is very appropriate. And even more appropriate is that it's private fun. Private fun is always better than public fun. You know what I mean? So, by default, you want things to be private. Basically, you want to hide visibility of methods or variables. So you want things to be private. So we're having a private function here called assign numbers to buttons. If you wanted to access this function or method from another class, of course, you have to make it public. So the way I'm going to do this is I'm going to define a random number generator. Let me pull up. So what I did here is I imported at the top java.util.random, which is where the package name where this random class is located. And then what I can do is I can say r.nextInt. And then you have to bound. The parameter you can pass in here is a bound. So what is the maximum number you want to pick? So I want to pick 10. So that'll be the left number. Now I'm going to do the same thing for the right number. Right num is equal to r.nextInt. Right? And you'll notice here, the way I declare a variable in Kotlin is val. There's actually one more way to declare a variable in Kotlin, which we'll talk about a little bit later. But val is basically the default way that you should be declaring variables in Kotlin. So now I have the left number and right number. These are integers. I now want to assign them into the text of that button. So I can say btn left.text, that text attribute. I want to update that to be the left number. And this is going to complain, right? And if I hover over left num, you can see why. Why is it not giving me the thing? Basically, if you look at the red light bulb, it says add toString to call. So the issue here is that you can see left number is an integer. But if you look at text, it's looking for a type of a string, or in particular, a char sequence, a character sequence. So in order to make this work, you just say left num.toString. And similarly for button right. This will actually mostly work. but there's one bug or one potential bug. Can someone help me out? What is the issue here?
Left and right num can be equal.
Yes, exactly. I think Kevin, you were the one who said that. So does that make sense to everyone? Basically what I'm hearing Kevin say is I'll have right num. I'm going to initially assign it deliberately to be left num, okay? And then I'll say while right num is equal to left num, I'm going to reassign right num to be another random integer. Okay, so let's run this and see if this actually works. So I'm calling this function assign numbers to buttons. So now, hopefully our game is a bit more interesting. So after I tap 5, we can see that the left one randomly happened to be the same number, but the right one did change to be 9. So if we do this again, you can see that it is actually randomly changing. Amazing. So one more thing to do, and then we're done with our application, which is we basically want to do something quite similar for the right button. So right now we have a left button click listener. I want to do the same thing, something quite similar for the right button. So it'll be the quite similar, right? I'm just going to copy over these comments. Pick new random. And number 2 is easy because we have a method for this, right? So there's actually not that much work. I'm just going to call this method, and number 2 is done. Now, number 1. The logic here for button right is going to be quite similar, except for the fact that now when the user is tapping on the right button, they're indicating an intent to say that the right number is larger than the left number, which is different from when they click on the left button. That's the only thing we have to encode differently. So one way I might do this, right, is I could just basically do something quite similar, right, like this, copy this. What's the thing I need to change? It is line 40. Instead of checking left num is bigger than right num, I need to actually flip this. So that's pretty good, right? What's wrong with this? Why would this never pass a code review? All right, Christian is saying we could break this into a separate function. I like it. So someone tell me more. Tell me first, what is the problem? And then what are you trying to solve when you say we can break it into a separate function? Yeah, that's beautiful. I love that. Does that make sense to everyone? Basically, what Christian is saying is that there's a fundamental concept in programming called dry. Dry means don't repeat yourself. The more lines of code that you write, the more bugs you'll have. That's like a fundamental fact of programming. You cannot write bug-free code. And so your objective as a programmer, one of the objectives as a programmer should be minimize the number of lines of code you write. And so when I copied and pasted this whole body, these whole like 10 lines of code or whatever, that should be a red flag. You don't want to just copy code blindly. The better way to do it, like Christian is suggesting, is create a separate function here and only pass in as a parameter to that function the information we need to make that decision. Let's do that. I'm going to actually undo this. And I'm going to take this and have another function here called private fun. What did I call it? Check answer. Then I'm going to call check answer here. So I haven't done anything different, right? Compared to where we were like a minute ago, this is literally identical, except for the fact that now I moved all that code into check answer. So now someone tell me, how can I, like, one thing I could do is I could do check answer like this, right? That doesn't work because now even when I click on the right button, we're going to be comparing left num versus right num. So someone other than Christian, can someone tell me how to, what should I do in terms of making a parameter for check answer? How can I fix my program based on what it is now? Perfect. That's exactly what I have in my notes. So I'm going to pass in a Boolean parameter here. So the way you pass in a parameter in Kotlin is you first say the name of the variable followed by the type. So I'll say is left button selected, and it's of type Boolean. One thing you'll notice is that in Java, if you're coming from a background in Java, you have these primitive types where you have a lowercase b Boolean. In Kotlin, you don't use primitives, you use wrapped objects, so capital B, and you can actually invoke methods on these objects. So we can pass in check answer, and we're indicating to this method, this function, did the user select the left button or right button? So here, the answer is yes, we are selecting the left button. And then on line 26, when we're in the click listener for the right button, we're passing in false. All right, and that actually is quite elegant, right? I mean, it kind of intuitively makes sense. When you think about this function, there's really only two options the user has. Pick the right button or the left button. So a Boolean, which is true or false, is like the exact perfect thing to model that idea of picking left or right. So now we have to use this parameter. Is left button selected? All I need to do is left button selected. So actually, let me do this. So I'll say val is answer correct. And the answer is correct if there are two conditions that are met. First, if the left button is selected, if is left button selected, then we do left num bigger than right num. Else, we do right num bigger than left num. This is called a ternary statement or ternary statement in Kotlin. So we're saying if the left button is selected, then we want to have this comparison. Otherwise, we want to do the opposite comparison. So now I can replace this with is answer correct. Let me zoom out. That's the completed program. Let's run it to make sure it works. All right, 5 is bigger than 3. I think that's correct. So now we have random numbers on both sides. Let's pick the right button. And now the right button should actually work. It worked, right? So now 9 was bigger than 7, that's correct. 5 is bigger than 3, that's correct. And now 1 is, let's just pick the wrong answer. So 1 is less than 5. Cool, it works. The one thing I would do if I were actually gonna submit this is at the very top in the onCreate method, right now we are statically defining in the layout file, the text of 5 and 3 here. But that game is not very interesting when you first boot up the app, right? So it probably would be better if we actually assign numbers to buttons right away. So the game is always starting off with some random selection. And one more thing I would do is, this is kind of a style thing. You want your code to be tight or dense, right? And so one thing that I try to avoid doing is if there's a comment which doesn't add too much value, I'll delete it. So for example, I wrote here like compare the numbers in the boxes. And then I have a method here called check answer. I think check answer as a name of method, it communicates pretty clearly, in my opinion, what is the idea of this method. So in reality, what I would do is I would just delete this one, delete that comment, and pick new random numbers. The value add of that comment compared to the method name here is not that much. So I would actually also delete this comment. So it kind of goes back to what we were talking about earlier, this concept of dry. Don't repeat yourself. So if you find that a comment is duplicative with the code that you wrote, then delete the comment. Because if you have the comment and the code saying the same exact thing, when you update the code now, you have the problem of updating the code. Make sense? Right, so that is it for this program, this application. I'll have the code on GitHub if you want to take a look. But before we go back now and do a structured overview of Kotlin, any questions? Amazing. Time to talk about Kotlin. So what is Kotlin? It's a programming language developed by JetBrains. And the 1.0 typically means the stable release of a project or a library. 1.0 was released in 2016. So right away you can tell that's actually a very recent or modern language. You can compare Kotlin to Java. Java is probably one of the most popular or common programming languages in the world. And Java came out in 1995 by Sun Microsystems. So similar to Java, Kotlin is statically typed and object-oriented. So statically typed means that at compile time, the compiler has to be able to identify a type for every single variable. That could be an int, a string, a list of string, a list of int, and so on. And object-oriented means that object-oriented programming is a paradigm where we basically look at the world and we create classes for different concepts of things in the world, different nouns in the world. And the idea of object-oriented programming is an object is an instance of a class, and these different objects interact with each other. And so object-oriented programming turns out to be a really, really nice way to model a lot of the interactions in programming, because they're really good at hiding data, encapsulating information, and structuring large, complicated programs. And so many, many languages today have adopted object-oriented programming, and Kotlin is one of them. And so one of the things that's really nice about Kotlin is that because it came out more than 20 years after Java, it incorporated a lot of the lessons from Java. So both the good parts it took in, and also learned from the bad parts of Java and made sure not to incorporate those when inventing Kotlin. And we'll talk about what those are in the next few minutes. The one last thing I want to mention on this slide about Kotlin is that the top priority is pragmatism. So this is something I really appreciate, because if you look at a lot of the kind of programmer mentality or hacker mentality, when you have a project, you oftentimes have this attitude of like, I want to burn it all down and then build it back up better and make it brand new with none of the old assumptions. And most of the time, especially when you're dealing with something so complicated like inventing a new language, that's not the right thing to do, because you're going to have your own assumptions. You're not going to understand all the assumptions made previously and why they were good or bad, and you're going to mess things up. And so one of the things about Kotlin is that it's deliberately trying not to reinvent the wheel. It's trying to be very pragmatic and work with existing tooling. And so one of the key tenets of Kotlin is that it will interoperate with Java. What that means is both Java and Kotlin will turn into bytecode. They both run on the JVM, the Java Virtual Machine. And that bytecode will turn into machine code. And so the consequence of that is that if you have a large code base or a large app written in Java, you can slowly start to migrate that app into Kotlin. And that's, I think, one of the major reasons why Kotlin has gained so much adoption in the past 3 or 4 years. I would say most of the production apps today are in that situation. So like I used to work at Pinterest, and they're actually still doing the migration. But the idea is that you can have like one module of your Pinterest application written in Java, and then another module, which is more modern and more recent, that can be written in Kotlin. And both of them will coexist in the same project, in the same app. And that's how most apps are doing the migration. The main thing is that very, very few things in technology are static, right? Like if you have any kind of meaningful app, guaranteed there's going to be a ton of feature requests and bug fixes that you have to make. And so given that knowledge that things are going to be changing no matter what, you want to be changing things using a modern, efficient language like Kotlin and not some old, crufty language like Java. And so that's why there's a huge emphasis right now in the community about migrating to Kotlin. Yes, there is. And in fact, it's built into Android Studio. So if you have an existing Java project, there's an option in Android Studio where it will try to automatically convert that Java program into Kotlin code. So that exists. And also you can go one step further. You can actually look at the bytecode. You can take a Kotlin program that you wrote and write the equivalent thing in Java, and then look at the underlying bytecode. And actually that'll be a good way, if people are really interested, that's a good way to learn the nuances of how Kotlin is different from Java by looking at the underlying bytecode.
Thanks.
So I want to convince you about using Kotlin in two ways. One is the community aspect, which is basically like ignore all of the technical reason, just follow the community. And what that means is look at what the people around you are doing, the companies or the people around you, and learn from them. So the idea here is kind of like a life philosophy thing that I follow, is that I'm typically not the person in the room who has the most information. or I'm typically not the person in the room who has the most knowledge or is smartest about a particular topic, right? And so this is going to happen to everyone at some point, right? Like when you enter in a new company, you don't know how things work in that company. If you're building a new app, you don't know what architecture to pick. And so 95% of the time, 99% of the time, what you should be doing is blindly following someone who has done it before you. Does that make sense? So if you enter into a company, the first thing you should do is find someone who is a tech lead or someone who you really respect and just blindly copy what they're doing and do it the same way. And so if you take that logic, then there's a really compelling reason to go to Kotlin. Google I/O, which is this huge developer conference, in 2017, Kotlin was announced as a supported language for Android. And then Google I/O 2019, Android became Kotlin first. And what that means is that all of the new documentation and code labs and libraries that the Google team develops, they'll be written in Kotlin initially, and then Java secondarily. So that alone should tell you that all the smart people at Google, or all the smart people who have, created this Android ecosystem, they are pushing Kotlin really, really hard. And that's one really good reason to learn Kotlin. The other thing is kind of what we talked about earlier. More and more companies are adopting Kotlin. Because Kotlin, you can have this piecemeal adoption strategy. You have this really nice ability to take a legacy code base and then slowly migrate that over to Kotlin. And most companies you're going to see in Silicon Valley or across the world are doing that right now. The other thing I'll mention here is that there's a lot of potential growth for Kotlin outside of Android. So Kotlin, because it's a JVM language, you can also use it on the server side. So if you have a backend architecture, you can actually use Kotlin to code that up. And in fact, there are also some experimental projects which will allow you to take your Kotlin project and turn it into an iOS app. I don't really know too many of the details behind it, and I also don't know if it's actually being used in production by any large company. But that's the kind of thing that it illustrates that Kotlin not only will help you with Android, but it's also a very rapidly growing language outside of Android as well. And then finally, I think that even if you're not interested at all in learning Kotlin for building your application, I think that learning another language, and Kotlin in particular, it'll make you a better Java developer. So I mentioned this last week, but the way you become, in my opinion, the way you become a better developer, the way you become more senior is by having opinions about things, right? That's how I look at someone who I really respect at work. Do they have an opinion about random topics in programming, architecture, and so on? And the way you form an opinion is by being able to learn different languages and learn how different platforms or languages approach concepts. So how do you iterate through a loop? How do you iterate through a list in Java and Kotlin? How do you concatenate strings? Those are kind of basic things, but you can also think about how do you make a singleton in Java or Kotlin? And when you start to pick up on how different languages do that, you can have an opinion about that. And that will serve you really well when you pick up a new language 10 years from now, or even stick with Kotlin, right? So now the actual mechanics of the technical reason of why you want to learn Kotlin. I took these from the Kotlin website. Concise, safe, interoperable, tool-friendly. So concise means that it's not going to be as verbose as Java, and I'll show you that in a minute. Safe means that there are built-in nullability checks. Interoperable is what we talked about earlier, which is that anywhere that Java runs, Kotlin will run. And tool-friendly means that all of the existing tooling that you have for your Java project, for example, your build system, almost all of that should carry over directly to Kotlin. So you don't have any large activation energy to use Kotlin. And finally, one thing which is Android specific is that there are Kotlin extensions, which basically means that Kotlin has developed a library where it'll make your life easier as an Android developer using that library compared to if you were using Java. So let me demonstrate this by going into the code. Let's say that we want to get the last element of a list. So we have a list. Here's how you declare a list in Kotlin. Val mylist is equal to list of 42, 91, 51. So I want all of us right now to code this up together. So here's what I want you to do. Open up a new Android Studio project. And then go to no activity. The only reason I want to create a new Android Studio project is because I want to be able to run some Kotlin code, which has nothing to do with Android. I just want to be able to run some Kotlin code and see the output in the terminal. So go to no activity, tap on next, and then call it whatever you want. Why don't we call it Kotlin class? All right, so when you do that, you should hopefully be seeing something like this. And so what I want you to do is just open up the directory where you have app, source, main. Maybe a faster way to do it is go into the Android view. Okay, so now hopefully you're seeing this, and let's go to new Kotlin file and call this Kotlin class. Is everyone with me? So now this is a beautiful canvas on which we will write Kotlin code. It's actually very easy. Can everyone write that with me? So the first thing you'll notice here is that in Kotlin, there's no need to define a runnable method or a function inside of a class. So I define, like normally, you know how you would have like a public static main method in Java, and that would be enclosed in some class. There's no need to do that in Kotlin. You just have fun main, and this is the body of that function. And when you write main is a special keyword, you'll have this green triangle icon. So I can run this method, and I should hopefully see hello Android devs printed out. And then at the bottom here, you can see the build is running. So while that's happening, by the way, I was going to get another poll from the room without actually using the polling functionality. How many of you have done anything with Java before? Give me like a thumbs up if you've done anything with Java. Nice. I like some people have mixed the like physical thumbs up versus like the digital Zoom thumbs up. I like that. Okay. And how about Python? Give me a clap if you've done something with Python. Okay. So so 106A, is it in Python? It's in Python now, right? Okay. So a lot of the content I'm actually going to be talking about kind of assumes some knowledge of Java. But if you don't have that background, because 106A is in Python, don't worry too much. In some ways, Kotlin and Python are actually quite similar. But I just wanted to kind of get a sense of where people are. All right, so now you can see that down here, we're able to see hello Android devs. So let's talk about the code I just showed you. We have a list, which is list of 42, 1991, right? So one thing you'll notice here is that in Android Studio, there's like this gray text which says list of int. So the type of this variable is inferred automatically based on the value of the variable. So it's kind of obvious from here. It's a list of integer. That's how we're able to derive that from here. So I want to just walk you through a really quick demo of why I think Kotlin is much more concise than Java. So if I wanted to get the last element of this list in Java, how would I do that? I would do this, right? I would say my list.get, and then I would say my list.size -1, right? And the reason is because I want to have access to this last element, which is a last index. And Java and Kotlin are both zero indexed, which means that the last element is going to be the size of the list -1. What you'll notice here is that Android Studio is complaining and it says, hey, instead of saying .get to access an element, you can actually replace it with indexing. So this is equivalent to my list with the square bracket notation, right? That's pretty cool. this pattern of getting the last index of a list is actually so common that there's a shortcut for this. You can say my list is my list dot last index. That's nicer, right? And there's actually one more step I can take. This pattern of getting the last element of a list is so common that Kotlin has made this even easier. I'm going to say my list dot last. So these 4 lines are identical, but going back to like Jason, what we were talking about, right? It's like, do you want to spend time worrying about the computer or the programmer? And almost always the answer is you should worry about your fellow programmer more than the computer. And so when I am committing code or if I'm writing code, this line, in my opinion, is so much more readable than this line. The number of characters is a lot less, and I think this communicates much better the intent of what I'm trying to do. I think the more levels of abstraction that you introduce, typically that results in more performance cost. And what I mean by that is the more you kind of have these syntactic sugar and the more you kind of make things really pretty, that typically means that there are more machine code lines that have to be executed. And so back in the day, like when they were doing things, I don't know, in the 60s and 70s, I think performance was at a premium. CPU was at a premium, CPU cycles. And so as that has been relaxed a little bit, I think there's a lot more tolerance now of being able to do this kind of thing because the computer time is so cheap, programmer time is not cheap. So almost always you should be preferring to write code like this.
Okay.
And let me prove to you that this works. I can say println mylist.last, and the answer should be 91, right? I'm going to run this again, and hopefully we should see 2 lines in the output. Hello, Android devs, and 91. Cool. So one thing I have the code on the sides, but one thing I really recommend is I want you all to write code down. And the reason is because if you go back to like Android Studio, you have autocomplete, which will hint at you like different things you could be doing better. And also you have these like, I don't know if you can see this yellow light bulb here, which says replace get call with indexing. So a lot of my learning happens because I can listen to the hints and suggestions of Android Studio. So the more you write code, the more you'll get familiar with that. Don't rely simply on the code in a slide. That's not going to give you that much. All right, so now I want to go through 3 quick topics, and then I want to do breakout rooms for a few minutes to give you a chance to write some Kotlin code. But the 3 things I want to cover are type inference, immutability, and null safety. So I'm going to actually... So in Java code, here's how you would declare some variables. And the thing you'll notice about Java is that you always need to declare the type. So you say string first, int age, list of a string, and so on. With Kotlin code, this becomes actually a lot cleaner. So you could explicitly declare the type if you wanted to. You could say val first is of type string is equal to Jane. Then you could, right away you can see that string is this gray color because Android Studio will tell you that this is unnecessary. Remove explicit types spec because it's obvious from the value here that this variable is of type string. So the better way to do this would just be to go ahead and omit that, right? You can do the same thing, val age. So then you might ask, why would you ever want to have the explicit type here? And the reason is because you do want sometimes to split them up. For example, if you have an object or a class and the constructor parameter is of type age, of type int. So in that case, you need to actually have the declaration of that type. And then later on, you would assign age to be, 42. And then if you want to declare a list, you can do something similar. You can say list of string And then I could say April, John. And then same thing here. I don't need to declare type string here because it's obvious that this is a list of string. All right, immutability. The concept of immutability is that once you declare a variable, it won't change. The value won't change. So here's how this looks in Java. You say int age is equal to 35, and there's no real concept of indicating that age is not going to, well, there is something called the final keyword. Final means that the value here won't change. But in Kotlin, this idea of whether something is changeable or not is baked into the language. You have to declare that explicitly when you declare the variable. So here you can just say age plus equal 1, which will increment age. In Kotlin, if you're going to modify age, you have to declare it as a var. Let me show that to you. Immutability. If I say age plus equal 1, you can see that it's complaining, right? This is red underline here. And the reason it's complaining is because val, it says val cannot be reassigned. So if I wanted to modify age, I have to go back and declare it as a var. And then I can say val other friends. Me. So with lists, it gets a little bit more complicated. So here I'm declaring other friends, which is another list, as a mutable list of, and that means I can now modify the contents of that list. I can say other friends 0 is equal to June, right? So I have a question now. I have two questions. It seems like var does everything that val does, right? Like anytime I could use a val, I could also use a var. So why not just go ahead and change everything to be a var, right? And I could still run the code just fine. So that's one question. Can someone help me with that? Why not just make everything a var? Yeah, safety. Eric is saying safety. Can you tell me more about that? Kevin saying the same thing. Some data you want to be read-only. That's exactly right. So basically, the number one source of bugs in programs is you expect some data or information of a certain way, and that data is either not of that format or of that type, or it's null, right? It's not what you expect. And so the way you can make sure that that entire class of issue goes away is by making data unchangeable. And the way you make data unchangeable is by declaring things as a val instead of a var. And that's exactly the reason why. So by having as many things as possible be val, your code will be a lot safer and it'll be more resilient to things like unexpected output or even crashes in the code. So I have one more question along those lines. So I just told you, like we just talked about how val means that you cannot change the value of that variable. So here in other friends, I'm declaring it as a val, but I'm declaring it as a mutable list and I'm changing other friends. So it kind of seems like a contradiction, right? So someone help me out. Why is this valid? Let me actually just show you. First, let me prove to you that this works. So other friend, I'm printing out the first element of other friends, and it should be June, right? Cool, so that works, right? Can someone explain to me why I can simultaneously have a variable called val, but also make it mutable list of? So it gets on, that's getting to something very, very deep that I want to mention, which is this, right? So I have a variable called friends, and I declare it as friends, and it's pointing to some list, right? So what we can't do, because it's a val, is we cannot reassign friends to be another list. This would give a compile error. But changing the contents of that list is valid. But the reference of where that list is pointing to, that cannot be changed. Make sense? So let me actually show that to you. So if I said other friends is equal to another mutable list of, invalid. So now I have this red underline here, and it says val cannot be reassigned. Cool. Right. Nullability is the last thing I want to talk about before we do breakout. Nullability is the billion-dollar mistake. That's what Tony Hoare described it as. He is credited for inventing null. He won a Turing Award for like doing a bunch of things in computer science, among them being inventing null. But he calls it his billion-dollar mistake. And actually, $1 billion is vastly underestimating the amount of damage caused by null. So can someone tell me what is null? Null is kind of this weird thing. In the context of Java or Kotlin, which is primarily what we're talking about here, null basically means that it's a placeholder for an object, but there is no object yet. And so what that means is that if you try and invoke a method or a function on that object, and it's null at that point, that will cause a crash. Kotlin does have this idea of null, but it guarantees some safety around it. So let me show you what that looks like. So I'm going to define a method here called findFriendScore. And then we're going to pass in the list of friends here. And it's kind of just like an arbitrary method I'm going to define. Let's define that. And what I want to do in this method is I want to basically go through the list and I want to sum up the length of each friend's name. It's kind of just some like arbitrary example. So in this example here, the answer should be 4, which is June, plus 4 from Mark. So the answer that's outputted should be 8. Okay. So the way I might do this is I could say for friend in, actually, let me rename this variable to just be friends. Okay, so the answer here should be 8, right? Cool, so that worked, right? Now let's talk about null. So right now, what we're saying here is that friends is guaranteed to be non-null, and the compiler will make that guarantee for us. It will enforce that. So what that means is, if for whatever reason, if I wanted to call this method with a null list like that, the Android Studio will tell me right away that null cannot be a value of non-null type mutable string. So if we did want to allow null, what we have to do is add a question mark here. And this question mark is really important. What that means is that we can not only allow this type, but also this nullable type. And so now the error is down here, because what this for loop is saying is that in the case that the parameter is null, then this would be invalid. So we now need to fix it by checking if friends is equal to null. Then we can probably return 0 here. And so if we've gotten past this condition, then the compiler is smart enough to figure out that at this point, friends is non-null, and we're able to properly iterate through this for loop. And this is actually really powerful, because if you compare this to Java, you can do something like this, right? You can say string name is equal to null, and then you can say name.length, and this will compile just fine. It'll happily compile, and when you go out to run your code, it'll crash at runtime. So the way you would fix this in Java is you would say if name not equal to null, only then do you compute the length of that. So in Kotlin, if you say val bad is of type string, that equal to null, that would right away give you a compile error because you have to declare it as a nullable type, a nullable string. And so you have to say string question mark. And so if you wanted now to say name.length, because name is nullable, it has a chance of being null, calling .length on it would cause a runtime exception, which is not allowed. So it would be a compile error instead. So it would actually be caught earlier in the process, which is a good thing. The way you fix this is you have this question mark operator again. You say name question mark .length. And what that means is if name is non-null, then we're able to properly call .length. If it is null, then we're going to go over to this question mark colon and assign 0 to length 1. And then you could also do something similar where you just check if name is not null, and then you can call the method on it properly. Any questions? Cool. Kevin's asking, are function parameters implicitly immutable? Well, that's a good question. Yeah, I think the answer is yes. So like, for example, if you have like a, so you can actually, you can add in the name of that variable, val or var, in the parameter. So in this example here, you have like a data class. So name cannot be changed. So I think it depends. I think you can't, if you, like in the Android Studio example here, you have a mutable list. So the contents of friends could be changed. And I don't know, actually, let's try if you can actually assign friends to be another mutable list. Yeah, so val cannot. So I think implicitly it is going to be unassignable. So it'll be unchangeable, a val. And then you could explicitly change that if you wanted to. Okay, so now what I want to do is the following. I have a link here, which I'm going to share with all of you. So are you all able to click on that link? And we can walk through it really fast. So what I want you to do is copy that, open that link, and then hit the raw button. And then in raw, you're going to have basically the Kotlin code, the starter code that I wrote. I want you to copy it, then go back to Android Studio and basically delete everything you have. So you're back to an empty screen, and then paste in what I gave you. So let me just quickly talk about what I want you to do here. So there are two methods that I want you to fill out with your group. The first is get exam grade. The idea is that you're going to be passed in an exam result. An exam result is something called a data class, which is a special kind of class, which is read-only data. And so an exam result contains the name of the student along with what score they got on the exam. And so what I want you to do is I want you to return a string based on the score. So give the student an A if they got between 90 and 100, a B if they got between 80 and 89, a C between 70 and 79, and an F for anything below 70. And the other thing I want you to do is count scores higher than, which basically I want you to iterate through this list. And I want you to count how many of the scores in that list are higher than the threshold. Okay, so I am going to split us all up into groups of maybe 3 or 4. That means that the parameters are being passed by value. So if you have something like a threshold, if you modify threshold, it's not going to be persisted outside of that function. But if you have an object, the tricky thing there is that the thing that's being passed is a reference to that object. And so if you modify the contents of that list, that will be persisted even outside that method. Hopefully that makes sense. Okay, so how did that go? Were you all able to get through some of these questions? Get exam grade. How did you do this? Exactly. So that was the main thing I wanted you to learn for this one. There's a construct in Kotlin called when. And with when, it basically is a nicer way of doing if else, when you have this kind of conditional. The way that works is you say return when result dot score, right? So the thing that we want to change is the thing we want to condition upon is the score of the result. So we'll say in 90 to 100, this dot dot notation is inclusive. So we're saying start from 80 and go up until and including 89. Then we want to return the value of B. And then if you're at 70 to 79, then we want to return a value of C. And we can also have an else condition here. That's it. And the nice thing about the when construct is that the when itself will return a value. So rather than having to define a separate variable and then setting the value of that variable inside of each of these, you can actually just do it in line with return when. Okay, someone help me out with this one. Count scores higher than. How do you do that? So does that make sense to everyone? There are two ways of doing this. One is you could have a for loop, similar to what we did. Oh, I lost it. Like how we had iterated through all the friends. You do a for loop. You could just check inside that for loop with a conditional if the score of that exam is higher than threshold. The other way to do it is Kotlin actually has some really, really nice functional approaches to problems. So let me show you, and that makes this one line of code. So I wanted to show you that. I'll say results.count. There's actually an inbuilt method here called count, and count takes in a lambda function. So what that means is this function will be invoked on every single entry of this list. And by default, the parameter name, like the name of that element is called it. So what I can say is it.score, right? So it is referring to an exam result. And I want to count it if the score is higher than threshold. That's it. And we can just test if this is working by running this. Oh, it looks like I screwed something up. 42 should translate to F. Wait, why am I not? Oh, yeah, this should be F. Okay, let's run this one more time. Okay, cool. The fact that there's no output means that all of these tests down here have succeeded. Okay, so any questions about Kotlin? All right, so it's 5:17, and I think we officially end at 5:20, right? So I think I'm a bit too optimistic. I'm always too optimistic about what we can cover in lecture. So I don't want to try and cram in the whole topic of Git and GitHub right now. I'm going to punt that until next week, just so we can end on time. Let me skip all this and just go to the end. So we'll talk about Git and GitHub next week, which is actually fine because there's no expectation to submit anything. I thought about how can I make it simple for each of you to submit some Kotlin homework, but I ended up deciding that that's not worth it. So there's no homework, there's no deliverable. What I would recommend though, is that, have you all heard of LeetCode? LeetCode is this platform where you can kind of just do coding questions, and they're very commonly used for interview. So that is what I found to be kind of the simplest way to give you all practice with Kotlin. Again, there's nothing that you need to submit, but I'm going to be sending out via Piazza links to these two LeetCode questions. And hopefully they shouldn't take you more than maybe 45 minutes. But I would recommend that you go through them just to give yourself a little bit more code that you wrote in Kotlin. And the other thing that I want you to do for next week is I have a 6-minute video about some of the shortcuts in Android Studio. So just go through that 6-minute video. Just if you are interested in becoming more efficient with Android Studio and learning how to modify and edit and navigate the tool a lot faster. I go over some of that in that video. That's all I had. Tomorrow is office hours. So if you haven't gotten Android Studio set up, or if you're stuck with something there, please come. Now is the perfect time to get that working, because next week I'm going to officially assign project 1, which is a tip calculator.